I guess this one. Okay. So thanks for having us. Thanks for the introduction, Bill. So we're here to talk today about deployment of systems engineering on Parramatta Light Rail. It's basically, does everybody know Sydney? Okay, excellent, good. It's up in the water, that's the one. What I'll talk about today is, what is Parramatta Light Rail and why is it important? Malika's going to run through the systems engineering objectives and some of the tools that have been deployed on the project. Then I'll have a bit of a chat about some of the system elements and how we're moving into the next phase of those. The delivery model that we've chosen and the implications on how we work things, and then wrap up with some key messages. So go along for the ride. So basically, one of the objectives of the key vision for the project is to support the Greater Sydney Commission's vision for the city. Now, if you are familiar with Sydney, that's not exactly, obviously it's geographically correct, but they're talking about 3 cities. Obviously, the harbour city, the eastern city, which everybody knows and loves, Harbour Bridge, Opera House, all that good stuff. Then there's does that work? Boom. Our western city, an aerotropolis out by Badgerys Creek Airport. And Parramatta is actually the geographical centre of that. So that's the middle city. And our job is to support that. So one of the objectives of the Greater Sydney Commission is to do the integrated land use and transport planning to create these 30-minute cities for people that can live, work, and get to places of interest within 30 minutes. And transport plays a big role in that. So actually, in our first team session, we had Jeff Roberts from the Greater Sydney Commission come and explain how we fit into the scheme that the Greater Sydney Commission has for the city. But that's the high level objectives. We're getting down to the brass tacks of actually delivering something. So we've got an alignment that runs from Westmead through the Parramatta CBD and up, replacing an existing single track rail corridor with a depot in Camellia. And basically this section here is running in road, adjacent to road traffic, and this is a segregated corridor up to Catenary. So our objectives for the project include city shaping, so helping to build Parramatta as the next big city. Connectivity, obviously, hey, we're a transport organisation, we've got to get that right, so connecting people to places. There's a placemaking aspect to our job. We're building light rail in front yards. It's not like metro where it's in tunnels, it's in people's front yards, so we need to leave behind places that people want to visit and go to. And attractive transport choices. So we're not just a light rail project, we need to consider the whole transport network. So I guess a bit of the glossies from some of the developments happening around. Westmead is the largest medical development in the southern hemisphere at the moment. So they're currently building, and we have to interface with them because we're butting up to each other. There's a precinct to the east of that, which is called the Cumberland Hospital. It's currently a mental facility. But Urban Growth New South Wales is getting into that and turning that into like a 3,000 person development. Parramatta CBD, and hey, that's a picture with all of these future planned towers that's going on in Parramatta, and some pretty immense structures being put up. And a Camellia near where our depot will be, there's an area that's sort of an industrial wasteland at the moment. That's going to be turned into one of the densest developments in New South Wales there. So it's similar to roads, similar to that. So, but actually, I guess I should talk about the transport project. So Transport for New South Wales considers that you are a customer from door to door to door. And I guess what that means is, when imagine you've got kids, for those that don't have kids, and you're thinking, oh, okay, I need to pick up that person, drop my kids off and pick them up from daycare. So you're actually thinking about your journey to work in what you have to then do after work. So we consider it door to door to door. The transport network of interest includes buses, ferries, roads, active transport, which is a fancy way of saying pedestrians, cyclists, and rail. I guess going back to that picture there, we have a current state of transport network without the red line. The roads work generally. There's footpaths, there's rail traffic, there's ferries. That's a working system. So it's a working transport system. Our job is not just to bash in the red line and not worry about anything else. We've got to move it from a current functioning transport system, put in our changes to a future functioning transport system. So you'll see that we actually have, as I talk through it, you'll see some initiatives in some of the other areas. Interchanges are important, and I guess the word from my customer experience people is that ideally people who don't recognise them as interchanges, they don't notice them, it's just part of a continuous flow of the transport network. And we also have a role in special events, which we're building near a big new Western Sydney stadium. There's all sorts of cultural events like Parramatta and so on that happen in the park areas, and so we need to support those. In terms of a current status, we have got a bit of a government approval to move forward. We've had an environmental impact statement out in public consultation, and the public consultation is now closed, so we're aiming to get that planning approval in April next year. We're commencing the procurement of the mainworks contractors. We've had the expression of interest go out to see who would be interested in bidding on the work. Thankfully, people do want to bid on it. And we're starting some enabling works next year. The system opening date is 2023, and we'll be busy until then. I guess that's sort of an quick overview of the project. I'll hand over to Malika to deal with the systems engineering aspects and objectives.
So thank you, Jonathan, for doing the introduction. I'll go through some of the objectives for the project that were set early in the process, really early in the piece at the beginning of the project. So one of the main objectives was to ensure that the system was going to be safe, reliable, customer-focused and integrated system of systems, which included the understanding of the needs of the transport system from a customer's point of view. We also had an objective around articulating the project objectives, including the project's responsibility to the community while still meeting the needs of the stakeholder and the customers at the end, including local bodies such as councils. Systems engineering needed to provide the backbone for quality and assurance processes for the project, and we needed to come out with a robust set of contract documentation that considered who was best placed to inform and make decisions on the system itself. So, as with most projects, there were quite a few documents generated. One of the main ones for this particular project was a business requirement specification, which informed many decisions on the project from the point of view when it was written into the definition design and currently into the contract specifications. So they basically capture the business and stakeholder needs and objectives for the project. The business and stakeholder being Transport for New South Wales. It described the changes to the existing transport system that was currently in place. This included modifications to the road system that needed to occur, as well as, in this particular case, the decommissioning of a heavy rail corridor into a light rail system. Requirements were elicited from all parts of Transport for New South Wales, making them contributors as opposed to just reviewers. So they were owning the requirements that were being written in the specifications. The audience was not just Transport for New South Wales as a cluster, but also the Roads and Maritime Services Division, RMS, which manages the roads for the network. And they were embedded into the project to help support this definition. And the BRS was approved by the Project Control Group and the Light Rail Control Group, from where it was managed change managed. So anyone who wanted to change the business requirements would need to put up a change or an ECP or a change proposal to the project to get approval before it was implemented into the project documents. So it was configuration, sorry, I just jumped ahead a bit, but the configuration controls to ensure that modifications were managed. So some of the challenges was articulating the difference between business requirements and other specification, other requirements of the project. So the business requirements define the problem space, and coming from transport, if you're familiar with transport projects, you know that this is not really understood, and so we spent a bit of time making sure that we understood the different levels of requirements. The business requirements defining the problem space with the business goals and objectives. We then had to separate them out from the system requirements, which were the technical system specifications used to define the solution. When a requirement was raised by a stakeholder, we assessed it to see if it was technical or not. If it was too technical, we made sure we captured the need and business requirements such that a system requirement could be articulated and captured later. And we parked a lot of those system requirements into a parking lot to capture in the later phases of the project. One of the other things that we did was set the context of the requirements around other project documents being created. So we created this document map, which included the documents that informed business requirement specification and how the business requirement specification informed other documents on the project and leading to the system requirement specification and the role of these things and how they were informed. So for example, we use the customer product strategy, which defines the strategy of customer needs being captured by the system requirements, a business requirement specification, which then defined the customer service specification, which led to requirements being captured in the system requirement specification. I'll go through a couple of examples of that in the next few slides. One of the other things that was useful in the project was a decision management process, which one of the technical directors at Arup came up with. He called them the product definition sheets, and the main point of difference was they were articulating technical decisions that needed to be made. For example, how wide was the track gauge on the network, the length of the vehicle, and these technical decisions were then put through the project. Each issue was then assessed as to which group was most appropriate to inform that decision and make the decision. And so there was 3 levels of control mainly. The project control group, which is at your project director level, he was the best place to inform that decision. We then had, so for example, as an example of some of those technical issues, we had the service, yeah, headways and things like that were determined by the project director. We had decisions made by the Transport for New South Wales project team, which included alignment decisions and interfacing issues with other light rail systems. Then we had decisions that were left to the authorised engineering organisations. For example, if you're a light rail designer, you're probably best placed to make decisions on something technical to do with the light rail vehicle itself. One of the other things that we undertook was a multi-criteria analysis to determine different route options for the actual light rail project. So in many cases, there was a number of ways you could get from stop A to stop B, and how we assessed them through picking the right route was against the project objectives that Jonathan went through earlier. So going from business requirements into the system requirements, we had to come up with a way to make sure the transition to the system requirements was as complete set of requirements that defined the scope for the system. So we went about creating a system architecture report, and which meant with the main objective of describing the logical description of the system, the physical description, as well as interface definition. For the logical aspect, we ended up creating scenarios of how the users would interact with the system, be it a passenger or customer travelling using the Parramatta Light Rail system to travel from A to B, the driver itself and its interfaces from the depot to the vehicle to the driving the light rail through the system, getting off at a terminus, turning around, coming back. We had scenarios for the role of the operational control centre operator, and we also had a couple of scenarios on some of the interfacing with the Parramatta Light Rail system, such as your road drivers, your cyclists, your pedestrians, so we could understand the transport system as a complete system, not just the light rail system. So as an example, this is an activity diagram that we did for customers travelling through the Parramatta Light Rail system. So you can see, as Jonathan explained, the door-to-door experience of a customer. So we start off with the customer planning their trip, making their way through either a different mode of transport, like active transport, the bus, or heavy rail, or a taxi even to the light rail, or even walking. They navigate their way through to the stop with wayfinding. Then they access a platform. You need to make sure that they're accessible to all types of customers. Either topping up your Arup card, which is the way we pay for the system, or just tapping it on so we could get charged. Then we wait for the vehicle, so then we need to ensure that there's functionality described to make waiting for the vehicle, boarding the vehicle, travelling on the vehicle itself, disembarking, tapping off your card, and then coming to the stop, departing the stop itself, and exiting the system. There was even a point that we needed to get feedback from our customers so that we could improve the system over time. By doing this activity flow, we were able to articulate the functions, which are these boxes down the side, which define the things the system needs to be able to enable in order for the customer to get through the system efficiently. And these functions need to be captured by the system requirement specification. And that's, I guess, it was useful to use this tool to help talk to different parts of the project. So we could put this in front of our technical director and they would understand it, as well as systems engineers who need to understand what functions they need to capture in the specifications, without necessarily becoming light rail experts. So we use them to help identify touch points and make sure they were catered for, and we use them also to ensure the system is adequately specified to meet the overall user needs. One of the other things we went about doing was setting up system architecture as a system of systems. We have the Parramatta Light Rail system, which is, I guess, part of a wider transport system itself. But in the Parramatta Light Rail scope of work, we have the light rail system, we have the roads, we have active transport, public domain utilities, as well as other systems. And I guess the thing is that these are independent systems that have their own functionality. But when they come together, they create emergent properties, which are in themselves an issue. And we need to ensure that we design for them. And to ensure that we design for them adequately, we ended up going through an embed analysis to identify interfaces between these systems. And everywhere there was an intersecting point in the embed diagram, we made sure that the requirements were specifying both sides of the system, so they could both be designed to meet that interface once they were implemented. While the other, we were fortunate enough to have a digital engineering team embedded in the project. But I guess just to explain this piece around digital engineering, the main objectives was to enable asset information to be collated in a consistent format across the industry. And there's currently a piece of work being done to standardise this within transport. So I guess the thing was to create a link between when you come up with an idea of a system and how it goes through the project lifecycle to get to the actual asset information model. In systems engineering, we all understand this as the configuration arms, but in infrastructure this is pretty new. And talking about system as a concept of an idea, taking it through a project information model where you collect data such as your design drawings and documents for as-builts, and then moving it into a final asset information model, which is what the operator and maintainer use to maintain and operate the system over time. So you can see the development of the system breakdown structure during the course of the project. I guess to reflect on some of the things that we could have done better around the system architecture space. I guess we were a little bit late in coming up with the system breakdown structure. We had one which was a little bit detailed, and it wasn't necessarily helping inform some of the interfacing between the system of systems thinking. And we did come up with it a little bit later, but I guess it hasn't been finalised, and there's a bit of work still to be done to complete it and get buy-in from the various parts of the project. So it's a bit mature, and I guess over time, if you had more time, the project would probably be able to resolve some of those issues, which we're currently still working through, and get it accepted by the wider transport cluster as a way to describe system of systems. The other thing that we did was create So following on from the system architecture work, we get with a system requirement specification. Originally, we created a split in the system requirement specification between the infrastructure specification, which is your track, your overhead wiring, versus the light rail vehicle itself that travels through the system. During the course of the project, we realised it probably should be collated into one system specification to describe the overall performance of the system that's required to meet the business needs. So we collated them into one and then added operations and maintenance requirements into the system requirement specification, so it's a complete system, including the operator maintainers role in that system. We ensured that the decomposition of vague business requirements was articulated into verifiable system requirements. So just as an example, we had a requirement that the PLR must provide a level of comfort equivalent to other light rail systems in the business requirement specification. And two examples of some of the system requirements we came up with was the PLR system must have 50% canopy at some of the stops to ensure comfort for customers waiting at the stop. And we also had another one around the LRVs must incorporate recommendations from the prototype testing of customer areas, which was going to go do a prototype of the layout of the vehicle and get customers to come in and give their feedback on the layout of the vehicle so that we could design it into the system. These two requirements were more verifiable and articulated what the comfort meant at the business requirements level. And we also captured the outputs from the system architecture, like the logic and the functions that we needed to capture into the system requirement specification. Following on from the system requirement specification, we went about creating the system scope and performance requirements, which is what we use in transport to create contract specifications that we go to market with that end up meeting the business requirement specification and business requirement specification. We're currently in the phase of finalising these documents, so they're in a state of finalisation at the moment, and there's still a bit of work to be done. And I guess some of the issues that we faced while we were writing the system scope and performance requirements was that some subject matter experts were utilised to write these requirements as technical SMEs in the area. We gave them rules and templates on writing the requirements, but we had a couple of challenges, obviously, as they're not requirements authors. So some of these SMEs have come from other light rail projects, and they wanted to use the last specification they wrote because it was used adequately to go and procure a system, and which didn't necessarily follow the system engineering approach. And the system is so well understood, a track is a track. It's not like between the projects there was only going to be many changes in the definition of that track system. Through the course of the SMEs writing the requirements, even though we gave them instructions to maintain traceability back to the source requirements, we lost that traceability. Some of the SMEs were good at maintaining that traceability, but some of them ended up losing that information, valuable piece of work that we had done in the past. So in order to help recover this, we ended up going through and using a tool called Respecify, which is a new requirements engineering tool and helps you author requirements in a way that's constructed in a consistent format with grammar, with a constrained grammar in the background, and it creates your definitions table for this particular specification as well. Finding it useful to help clean up and resolve some of the terminology differences between the requirements spec written by the authors. And the activity is still ongoing to complete the traceability between the SPR back to the SRS and the BRS. So I'm just going to hand over to you now.
Thanks, Mike. So I guess cut my teeth on a lot of the systems engineering processes on the Waratah Trains, which was a train project in New South Wales, and I think Data and Engineering actually run a good process there, so we can learn a bit. So I guess I can relate that to the light rail vehicle, which is part of our system. It's actually fairly well encapsulated. Yes, there's interfaces with the track and stops and all that sort of system, but a lot of the functions are encapsulated within the vehicle. But I guess this is now talking through some of the challenges that we're facing. The light rail vehicle is actually part of the light rail system, which includes, as Mike referred to, it's not only got the track all the systems and the vehicles, but also includes your operations and maintenance functions carried out by one of our contractor to us. We've got a road system, which, whilst we can influence, we cannot control driver behaviours. So there's an interface there because we're running adjacent to to roads and track, not generally what you have in a heavy rail corridor. And we've got a public domain which effectively provides amenity for people and public get around and enjoy a recreational space. Noting that whilst the transport light rail assets will be owned by Transport for New South Wales, Roads and Maritime Services own the roads, or council own the roads, and council looks after the public domain as well. So we've actually got multiple asset owners that we're delivering into. Then you overlay like a function like drainage, and you'll see actually all three of those elements actually feed into the performance of the drainage system. So, you know, road and light rail drainage and trunk drainage, as well as the surfaces created by the public domain, roads and light rail, all feed into the performance of flooding and drainage of the system. And then the challenge is to take all of that and bash it into a street environment. So it's been referred to as it's not a magic pudding, the street. You can't just keep jamming stuff in there. It's actually quite a robust design process that we have to go through. So we have to get all of those things into the street, and by the way, the street already has some occupants underneath, which are utilities. And so the forming and designing of all of these elements together is actually a real challenge. But I'll talk through each one of these sort of elements in a bit more detail. So our light rail system, we're offering turn up and go services. Basically during the day we're offering 7.5 minute headway on our service with 10 minutes and 15 minutes on the shoulder and nighttime periods. Here's a bit of a journey time map. We've got 45 metre long light rail vehicles with 100% low floors and air conditioned, seating about 250 people if you go by what our customer experience people want to plan by, 3 people per square metre, or if you want to jam them in a bit more standard planning practice, 300 people per vehicle. We want to, for the light rail vehicles, we're only buying in the order of 16, so we want to get an off-the-shelf product rather than something bespoke, and I don't think anybody will offer us a bespoke system. We've got a stabling maintenance facility. It's actually future-proof for our future fleet size of 41, which would consider demand up to 2051 and several stages of project. As the technical director at Arup likes to say, you don't find this sort of site in the middle of the city without having to deal with some contamination. So we're having to deal with some chromium-6 and some asbestos. It's right next to the James Hardy site. So that'll be fun. We've got structures on the light rail system. Here's Lennox Bridge, which has a bit of history in Parramatta. There's actually 3 parts to it. There's an old wooden part which is buried in there somewhere. 1839 masonry, beautiful arch, and then this abomination of a 1935 concrete structure which can't actually take the light rail loads. So I guess they didn't really build them like they used to. So basically we've gone in and tested that whole arrangement to make sure that it can take the light railroad loads, and it's all good. We've got a new structure over James Roos Drive. Part of the decision making that we've been going through in this process is who's best to make the decisions. So with James Roos Drive, we've said, okay, this is an arterial road that we cannot interfere with, so it's a client decision that we grade separate that. Now, we've shown an artist's impression of that bridge, but actually what we're doing is we're saying we want to get from point A to point B with a clear span over James Roos Drive. Mr. Contractor, you're best placed with your expertise in bridge building and so on to be able to inform that to a further state. So we haven't gone too far in defining that. We've just done enough to ensure that it's feasible, and we'll pass that to the industry to deliver upon. We're also modifying a bridge over Parramatta River to put 2 tracks, and again, an artifact of the transport network thing will be slotting in an active transport link attaching to the side of that bridge. It's a decision that has to be made as a client team. The contractor will not come back with those bits of scope against the performance requirements. It's us that need to say we want to have active transport across that bridge. We are dealing with some innovations as well. Hey, we all know Catenary maybe. We're going Catenary free in some areas. We've selected a couple of areas where we want minimum areas of wire free, and that decision was made in conjunction with discussion with the 5 different LRV suppliers, providing them our gradients and our distances and our stop distances and some assumptions around operations, and they came back and confirmed that it is possible, so we could go ahead and specify it, but we're not going to preclude them coming back with a system that might be entirely wire free if they can see the benefit in that. Onto the roads. So yes, we have a functioning transport network road network in Parramatta, barely. There's some areas, so we're going through and doing the appropriate modelling. We've done the mesoscopic modelling with AIMSUM. We've done microscopic modelling on key intersections with SIDRA, and we're actually doing a light rail operations model with VISM as well. So the road system is interesting because we actually have to deal with 2 legislations. We've got the Rail National Safety Law and we've got the Roads Act. And for our project, both apply. So there's some interesting road rules. So those from Melbourne would be probably familiar with the light rail / tram rules. But in Sydney, it's a little bit new. We've mapped all of our freight and servicing requirements, and those will be passed over to the contractor as requirements to ensure that we maintain the accessibility to the properties. We'll be specifying design and check vehicles at every intersection, so that the geometry of the intersection needs to be designed to accommodate those, with swept paths to ensure safe movements. And we also stumbled upon, we have to do driveway assessments, and effectively because we'll be asking people to drive out of their driveway into effectively a parking lane, because light rail's taken up the middle of the road, a lot of the driveways need to be modified to accommodate that. So further talking about that system, we can't put light rail in the middle of the road and not build the road capacity in other areas. So we're building road capacity on O'Connell Street and turning George Street into a 2-way street, and that needs to be in place before we shut the roads down for construction of the light rail. So that is really the majority of our networks, creating that traffic capacity. Urban design and public domain. Actually, one of the things that I've learned on this project is the importance of good design. You don't go to your engineer necessarily, and sorry if I'm offending any engineers, you don't go to an engineer to design your house. You go to an architect to do that design. So we've circled back and taken what was an engineering based on constraints and all of these good things that we work through in systems engineering, to give you effectively the least worst option, to then go through and with a design process and challenge some of those constraints, challenge some of those requirements, so that we can come up with the best option, the best design that we can come up with. So we've been working through that at effectively the city level, which inform the route precincts. So how the light rail moves through the streets and stop locations and how those are optimised. The street interchange level, getting down to the brass tacks of we're looking at trees here and there, and then some parameters, safe, clear distances that because we're a line of sight system, need to keep trees out of the way of the drivers. So I guess that's wrapped up in some urban design principles, and if you want to, I believe on the agenda there's a smart versus smart-ish. Who's doing that?
Nick.
Oh, Gareth? Okay, yeah, okay. So that might be interesting. We're going to apply some of that thinking into the urban design requirements. So we've got a couple of interesting areas along the alignment. We've got Eat Street, which is a pretty catchy name for a place where you basically have a lot of outdoor dining. That's actually set up pretty well for light rail, so we'll just be replacing road traffic with light rail, so you don't have to have petrol fumes with your dinner. So there's East Street. Westmead, as I said, it is a massive medical development there, and we're providing 2 stops in that precinct. And we have to worry about things like if somebody has a kid in their car and they drive past the entrance to the hospital, they've got to have circle back routes so that they can get the entrance and not have to be in a massive panic. So there's integration with our street and the development. We've got some particularly sensitive heritage areas along our alignment. This is the female factory, which has a bit of a checkered past in Australia. There's abuse and so on. So I think that aspect needs to be respected and treated appropriately. And I guess by understanding the past, it makes us realise how good we have the current world. Stop integration, yes, hey, we've got stops in the streets. When we were going through our MCA analysis, we recognised that actually it's like a teleporter. You don't necessarily care where the alignment runs, but where the stops are is really important for that sense of place. And so some gratuitous flooding pictures. So you may have recognised Lennox Bridge from that previous picture. This is April 1998. So we have to deal with a ton of water coming down the Parramatta River. These people don't seem too worried about the water though, but hey, that's not normal. So we've gone through and we've done a flood model, which is, we've spent a lot of time and money and expertise in this. The council almost fell over themselves when they saw how much flood modelling we had actually done. We've got a general requirement to have no impact on properties up to the 1 in 100 year event, which they've now changed the terminology to the 1% annual exceedance probability. And we've also put in effectively a business requirement that up to the 1 in 20 year event, we can operate our service. We're targeting better immunity, but we have to consider climate change, which is 400 mil raise of sea level at the lower bound, and also future-proofing for the council's upgrading of their system. So in terms of the specification process on this, we're specifying this at even though we've done a concept design with pipes in the ground to model, we're specifying a performance level, which is those are the performance requirements. We're not saying you need to deliver us this pipe network. You have to meet this performance requirements and verify it through a flood modelling approach. Onto utilities. Now, we've had a specialist utilities management team in our midst, and this is actually one of the things that have shown the power for digital engineering for me. They got all the data before you dig data, and then ran the clash detection with our alignment to understand what the utilities of interest were. And when you're talking in the 500,000 sort of utilities that could have potentially been of interest, they got it down to 17,000 pretty quickly. We then uniquely identified every utility, and then when they went out to do the ground penetrating radar, they had the IDs of the utilities they needed to find. So when the data came back from the survey, it was all uniquely ID'd, and you could do the clash detection on improved data quality, which got down to within 300 mil vertically and horizontally in accordance with the Australian standard. In terms of specifying for utilities, we've got basic design manuals, which our utilities teams work through with all of the utilities providers and agree the rules of engagement, effectively the specifications. If it's within this, you have to move it outside the hazard zone. This is the process you need to follow through. We don't have a single design process with all of the utilities. They've all got their own processes, and those are documented and will be part of the requirements we expect from our contractor. We've also done treatment options, which is effectively like a concept design. Those won't be mandated, but provides the contractor some of the cost. EMC is an issue, and they've had issues on other light rail projects around the world, so we are cognizant of that. We did a desktop study to identify what the critical sensitive receivers would be, and then we followed that up with a survey a written survey asking them where their equipment's located, what equipment they have, and asking for their manufacturer's information. So we've got a working group, we're part of the technical working group that's working with the medical precinct to look after EMC and noise and vibration. And apparently rats are sensitive to noise and vibration, who would have thought. Human factors. Human factors plays a role in, this was just down the road from you guys. Some old lady driving onto a light rail corridor that wasn't designed for road traffic. But basically, we need to consider human factors across not just the people operating the line of sight of the drivers, etc., but the people that we interact with, the road users, the pedestrians, and we also need to consider the wider system. So Transport for New South Wales currently has an existing light rail in the city. They're building a new one all the way down George Street. We're building one in Newcastle and one in Parramatta. Conceivably, you could drive through all of those areas in one day, and you don't want to be confronted with different road indications, different configurations of the rail network that would lead to confusion and potentially safety issues. So we're working with the Asset Standards Authority to ensure that we've got a common approach to those sorts of things. Sustainability, and I guess I've got to give my sustainability colleagues a bit of a wrap. Safety is embedded in everything that we do. I think we need to get to the point where sustainability is also embedded in everything we do. So we've had sustainability on the project since day one. We've done materiality assessments over the life cycle and identified the critical issues. So we are going to give ISCA target ratings, which is the Infrastructure Sustainability Council of Australia ratings, to the contractors, but we've done enough work to identify some initiatives that we want and we'll be specifying. And the important thing with the sustainability initiatives is it's not a separate section of our spec. It's actually embedded all of the requirements that affect the assets into the asset specs. So for instance, there's a concrete fly ash specification that has been brought into, say, the bridge specifications rather than off to the side in a sustainability spec. So which then leads us to the delivery strategy. Okay. So just to add a degree of difficulty, we've decided to go with a disaggregated delivery model. So conceivably on the Sydney Light Rail project, it's an aggregated delivery model, i.e. everything's all together in one contract and delivered. They have to manage all of the interfaces, etc. We've decided to go with a disaggregated delivery model, splitting off the infrastructure, which is basically almost everything below ground, track, roads, utilities, the public domain, which is above ground, all the bridges, etc. So that's the infrastructure contract. And then supply, operate, maintain, which is supply of the fleet, operations and maintenance of the system, sort of the stop canopies and the systems that go on that, all of the systems and the depot. So the reason why we did that was because we wanted to choose the best operator and maintainer for our customer, not based on the best civil price that we could get from our contractor. Also, we are looking at augmenting the system with future stages, and if you have that all tied into one big contract, then it's a lot harder to then break off the operate maintain portion to deliver the stage 2. So that's our delivery model. The implications on that, on our systems engineering process and our specifications. So rather than the client being the system integrator, we've decided to make that the responsibility of our supply, operate, maintain contractor, the SOM. And the SOM gets to input into the infrastructure spec during the tender phase. So ensuring that, hey, they've got responsibility for hitting our system requirements. You need to make sure that there's no gaps in the specifications between you two that will mean that the system won't meet those performance requirements. And the industry has stepped up to that and are quite keen to take that on. So if we had a single contract, I might have been tempted to not specify design stage and say, okay, you're a competent organisation. You don't need to, I don't need to prescribe to you what a design process is. You bid back that and you tell us what you want. Whereas now I'm going to be nominating the design stages so that the interface information that has to flow between the parties are tied to milestones, and there's a common language amongst those so that we can ensure that's happening. So delivery of interface information we specified. As Malak said, we've identified the interfaces between the two contracts, and we're going through an interface specification process there. We're going to have a stab at it, noting that that'll give our contractor a head start, and also they have the ability to comment on that through the process. Last point there is performance specifications need to be reconsidered. So where previously I had a flood specification about immunity being the 1 at 20-year event, we now have to break that into two to say, okay, infrastructure, you need to ensure that no water goes above 50 mil in the track in all of those events that you need to be immune for, and light rail vehicles, you need to operate within 50 mils of water. So on the track. So we need to break that performance requirement into two and allocate the responsibilities. So I'm not sure whether you're aware, but Asset Standards Authority in Transport for New South Wales have put in a lot of work to create these authorised engineering organisations. This is information from their charter, which shows that parties up the line can benefit from the assurance that an AEO provides at the lower level. So the SOM will act as the integrating authorised engineering organisation, ensuring that the interfaces between for all of the systems work together, and that the system output works. But if the infrastructure is responsible for their assurance. So if the bridge fails in 10 years and doesn't meet the design life, it's on the infrastructure contractor, not the SOM contractor. We're not expecting our SOM contractor to open up the assurance of the infrastructure and interrogate that. That's their the infrastructure's responsibilities. And we'll have a configuration management process that sits with the SOM. In saying that, going up through our governance process, we need to ensure that not only the contractors but our project team is carrying out our activities for diligence appropriately. So there's a configuration management process that sits at an enterprise level with Transport for New South Wales that we'll be complying with. So I guess wrapping it up into some key messages. Systems engineering and systems thinking will be inherent to the success of Parramatta Light Rail. Systems engineers bring a valuable skill set and a toolkit that a client and delivery organisation needs to resource appropriately. Systems engineering needs to consider the constraints, and I've tried to talk through some of those constraints that we're dealing with, multiple stakeholders, different commercial arrangements, and so on, and needs to be cognizant of that. And we need to try and balance the ability for the downstream entities to be able to innovate versus prescription and who's best placed to make decisions. So for instance, on the roads, we're best placed as a transport organisation to nominate the road lanes and so on. We can't give them a traffic model and say, hey, make it work. So, thank you. Open to questions, I guess.
So we've got about 7 or 8 minutes for questions.